Hi everyone. In this class we are going to see the next two problem for graphical method. Here the first problem is solve by graphically. Maximization of z is equal to 5x1 plus 4x2 subject to the constraints are x1 minus 2x2 is less than or equal to 1, x1 plus 2 x2 is greater than or equal to 3, x1 comma x2 is greater than or equal to 0. As usual, you have to change the inequality to equal form and then you have to substitute x1 is equal to 0, we get x2, x2 is equal to 0 means we get x1 point. For these two constraints we have two lines. For here, listen, this will be less than or equal to and greater than or equal to form. So, for the first constraint x1 minus 2x2 is less than or equal to 1 means for the line below region. x1 plus x2 is greater than or equal to 3 means for the line above the region. So, the common portion is not there. So, this is the example for unbounded region. So, for here listen, x1 minus 2 x1 is equal to 1. So put x1 is equal to 0 means we get a point x2 is equal to 0.5. Similarly, the next one is x2 is equal to 0 means we get a point x1 is equal to 1. So the points are 0 comma minus 0.5, 1 comma 0. Similarly, for the using the second constraint we get a point 0 comma 1.5 and 3 comma 0. So the common portion means in the above region, because for the constraint x1 minus 2 x2 is less than or equal to 1 means we have the bounded value, that is the below the line, this is the above the line. We have the common region but not entered. So here we have to write the conclusion like this: the maximum value of z cannot be founded because of occurs at infinity only, because here the intersection points are there. Be it using these two lines we hit a point, but the objective function is maximization of z. So you have to find out the corner point in the above. Should be definitely infinity. That's why we have to write like this: the maximum value of z cannot be founded because it occurs at infinity only. So the problem has an unbounded solution. So there is a no common portion means we have to see there is no feasible solution. Here we have a common portion but the end point we can't find because the problem is maximization, so we can't find out the end point. So you have to write the conclusion like this. The next problem is we have to find out the maximization of z is equal to this, and similarly we have a negative point in the inequality. So x1 minus x2 is less than or equal to 1, minus x1 plus x2 is less than or equal to 0. So for here is less than or equal to minus 1 means that will be in the above the line. Less than or equal to 0 means that will be the below the line. So here there is no common portion. So we have to write a conclusion like this. As it is, you have to find out what is x1 point. x1 is equal to 0 means what is x2 value. Similarly, x2 is equal to 0 means what is your x1 value. Similarly, using the second constraint also, you have to find out the points. First, you have to plot the points and draw the line. Afterwards, we have to come with the conclusion. So here there is no common portion. So you have to write like, from the graph there is no common portion, therefore there is no feasible solution. So the problem cannot be solved. Such a problem has no feasible solution. So the third problem is the example for you have a common region but the maximum point we can't find, it will be occurs at infinity. Fourth problem is the example of no feasible solution because there is no common portion. So graphical method means you have to clear about this. First you have to find out the points using the inequality constraints. So first you have to change the inequality constraints to equal form, and then you have to substitute x1 is equal to 0 means we get a x2 value. Similarly, x2 is equal to 0 means we get a x1 value. So you have to plot the 2 points and then draw the line. That should be less than or equal to means for the line below the point, greater than or equal to means that line above the points. So you have to careful about this. Thank you.